Today we're going to talk a little bit about molarity. Molarity is a unit of concentration. It tells you how much of a particular substance is concentrated into a solution. So molarity has the symbol M, stands for molarity there, right here. And molarity is, technically speaking, the moles of the solute per liters of solution. Let's be clear about what those terms mean before we move on. Solute, solvent, and solution are summarized, I think, pretty well in this picture right here. Solvent is usually the liquid that you are dissolving it in, and 99% of the time it's going to be water. Doesn't have to be, but 99% of the time it is. Solute is whatever it is that you are dissolving. Oftentimes it's a solid, but it doesn't have to be. It could be a liquid, it could be a gas. Those things get a little bit weird and wonky in there. But generally speaking, we're probably talking about a solid there. So that is the solute that is there. And when you mix the blue solute here, for this example, into the solvent, then you get the solution. And the solution is the two of them together here. So we've got some extra solute there. That's not what I'm talking about. I'm talking about the solution here. So the solution is what happens when the solute here goes into the solvent. So molarity is the moles of the solute that is there per liters of the solution, which can cause a little bit of confusion occasionally. So what we are going to try to do here is we are going to try to make a 1 molar solution. And for a 1 molar solution, you need 1 mole and you need 1 liter. But it's a little bit more complicated than that, because the mole is the mole of the solute, and the liter is a liter of the solution. Remember, there is solute, solvent, and solution. Now, that doesn't seem like it's that big of a deal, but it actually is a little bit. So first of all, let's see if we can't try to get our mole of solute. All right, so what we're going to try to do here is get a mole of the solute. The solute that we're going to use is regular old simple sodium chloride, salt. And sodium chloride, as you can see, has a mass of about 58.4, 58.45 or so. So we're looking for about 58.4, 58.5 grams of the sodium chloride. So how do we do that? Well, we get ourselves a scale, like so, and we put on a weigh boat, and remember that the weigh boat has its mass itself, so you're going to have to tear that out, which is just basically just canceling it out. And then I've got some pre-measured sodium chloride here, and if I pour that in, that should give us really close to 58 and a half or so, 58.4, 58.5. We are right in the zone right there. So that is 1 mole of salt. So that's 1 mole. The next thing we're going to look at is the liters. And here's really where the trick comes into this. This is called a volumetric flask. And what a volumetric flask is you'll notice that it only has 1 line on it. And that line is right here. Okay? And that one line is a very accurate depiction of 1 liter's worth of liquid that's here. So right now I've got water in here that is right at the line here for 1 liter of water, of the solvent. Okay, so that is 1 liter of the solvent. And now here's where our problem comes in. If this is 1 mole of our solute, and this is 1 liter of our solvent, is that going to make the correct molar solution that we saw before, which is this formula here? Now be careful, because the solute is the solute. That's not an issue. That's this guy here. That's 1 mole, and I need 1 mole of it. But you'll notice that this says 1 liter of solution, not solvent. What do I have here? I have 1 liter of solvent that is here. Well, does it really make that big of a difference? Actually, it does. Why? Well, watch what happens if I were to take the 1 mole of solute and put it in 1 liter of solvent. Now, keep in mind, I already have a liter. It's already kind of perfect right there at the liter. But if I go and start to put this solute in, watch what happens. All of a sudden, we can tell that we have gone above our line here. That's where we're supposed to be. We're supposed to end up right there. And it's not. It has gone well beyond that there. So what is happening here is I don't have 1 liter of solution anymore. What I have is above a liter of solution. What to do to fix this problem? Well, we've got the solute, that's not an issue. But the issue is the solution. But you'll notice, what does this formula not say anything about? It does not say anything about solvent. So how much of the solvent should I really be using? And the answer is, who cares? Enough. I need enough solvent so that I end up with 1 liter of solution. This formula does not take into account how much solvent is there. The solvent is just, you need enough of it to get 1 liter of the solution. So let's try this again. All right, so here we are here again. So we're going to put this guy on and we're going to tear him out like so. So now that I have 0, and again, if I put this in, it should be pretty close to a mole of the salt. So that's pretty darn close, 58.4, 58.5 grams. So now I have a mole of my salt. Now if I bring this over, I now have some water. How much? I don't know. It doesn't matter because the solvent is not important. What matters is that when I'm done, I end up at that point there with all of it mixed together. So what am I going to do is I'm going to take this salt and I am going to add it in to my top here. And once I add all of this in and get all of that in and swirled around and dissolved, then we'll see where I'm at, all right? But I won't be so far up that I won't be able to go over this line here. So I'm going to go ahead and add this in, and I'll see you in just a minute. I've now added in all of my salt and given this a good shake around so that all that salt is now dissolved. And so what I've got in here is I have got my 1 mole of my solute. So my 1 mole of my solute is now dissolved within my liquid here, right, within my solution. But now I need 1 liter of total solution. So I am currently here right now, and all I need to do is now add water until I get up to here. That will give me 1 liter of both water and the solute, the solvent and the solute together, and it will give me 1 liter of total solution. So what you do is you add until you get close to here, and then I'll show you how to get it just perfect. Right. I have now added enough water that I am real close, but I don't want to continue adding from a beaker like this because I might go over. So now what I'm going to do is I'm going to take a pipette, and I'm going to take a pipette and use the pipette to get a little bit of the water here, and then when I add this in, I should be able to add just enough so that I don't go over that line. If you need a little bit more, get a little bit more. And you want to arrange it so that the bottom of the meniscus, the bottom of that curve, is right at your line that's here. And that looks pretty good. So that one there looks pretty darn good. My water level is here. And now I have 1 liter of total solution. And dissolved within that, I have 1 mole of my solute. So 1 mole of solute per 1 liter of solution.